coming back. I hope you had a nice workshop, and you had enough coffee, and enough lunch, and you're feeling clojured because we clojured you, to pick up the term from earlier. We're going to start with the second round of talks, the afternoon, 4 more talks, going to have that. And we're going to start with audience participation. Just a question. What do you think is the first language any software developer should master or learn really well? So I didn't hear anybody say English because that is my firm belief. There was? Excellent. Thank you. We should chat later. Whenever people are, combining writing and coding, my heart opens up because I think they are very, very much alike. The type of abstractions and modularization that you need in writing is pretty similar to what you do or what we do in software development. So it is very awesome that we have somebody on stage today who is a writer at day and a coder at night. And so we have Alys Brooks from Wisconsin, right here in Berlin, talking about software that we can understand. Please welcome her with a big, warm applause.
Thank you for that very kind introduction. Yes, I feel the same way about English and programming. I guess I will say I am Alys Brooks. And besides being a coder and a programmer, a little about me. I enjoy taking photographs. And I am a cat person. So he is waiting for me, well, not waiting for me, waiting for his food in the United States. I also work for Gaiwan. We're a Clojure consultancy behind Lambda Island, and we make a lot of cool libraries and tools that you should definitely use. I'm going to cut myself off because I know everyone's favorite part of these talks is hearing about the companies, the solutions, the happy customers, but I'm supposed to talk to you about Clojure, so I'm going to do that. So has this ever happened to you? Maybe it's your first real Clojure project, and you're starting to get into it, or maybe it's a new project that you did not even write, and you're actually trying to get something working, and it's neither simple nor easy. It's complex. You might even say complected. And you're wondering, how could this happen? So that is kind of the situation I sometimes have when encountering a new code base. Many are not quite as dire as that. But so a lot of these problems have come out of real-world code bases I have encountered. So I kind of am thinking of these as like 3D problems, like the real-world problems. I think perhaps in 10 years, I will transcend to a higher plane of existence, and I'll be giving a talk to you about 4-dimensional problems and what that means. But for now, it's kind of in the real world where Clojure's tools come into conflict with reality. So the goal is to build a system that is intelligible, that you can understand, that you can modify. But what is the impact when it isn't that way? Obviously, I think probably it's really hard for a newcomer to understand at all. But that's not the only impact. Developers who are more kind of in the middle basically become beginners anytime they're in like a new system, subsystem, or in a new namespace even. Senior team members who've been doing this a long time and maybe even wrote most of it will come back, and if the system isn't really intelligible, they have to reteach themselves. And any of these people, when they're kind of serving a coaching or mentoring role, they spend more time explaining basic features. What does this even mean? Why do we use 5 different names for the same thing? that kind of thing, rather than actually solving the problem at hand or helping the person they're mentoring improve their skills. So it really impacts everyone, I think, and is not just, oh, let's make it a little bit easier for newcomers, because I think as you encounter a facet of something, you essentially are a beginner again. Yes. So the first power is the REPL. So perhaps you've been at the REPL, and you've required the core namespace of some app, and you do that, and everything runs. And then you're like, well, now what? What am I supposed to do to actually get the system running? So you're like, aha, I will look at the docs. And, oh, I don't know what to do next. So the obvious solution is, of course, to document. I'm a writer. I'm legally obliged to tell you that you should do more writing, and that writing is important. But I don't want to dwell too much on that, because people already know that. So I think another solution that fits very well in with Clojure is to have a lot of examples. And in Clojure, we actually have quite a menu of options. So we have REPL sessions. Jumped ahead a little bit. The examples are actually coming, but these problems are linked. So examples kind of address this one too. So REPL sessions are a technique we've used at Guy1 a lot, and they kind of provide a sample walkthrough of a namespace or of a kind of situation you might encounter. So here is a real-life example from our Regal library, which is for working with regular expressions. So it's a real namespace, so it starts with an NS form. And then we define a few things. And then the very next line of this file is just an example of a real regular expression, and then we start demonstrating the library, and you can kind of see right away, these are the tools I can use in this library or in this namespace, and this is kind of what kind of output they put. Like you can see right away, oh, it'll give me some nested vectors that make up the regular expression. So you don't have to wonder what the form is. And of course, you can go right in and edit these things if you want to know, if you're wondering about a particular part of the syntax and how, like a particular kind of regular expression syntax, and you're wondering how does Regal represent it, you could modify this pretty easily, and you would immediately have a Regal form. So it's very easy to answer questions you might have about this library from the REPL. So, yes. So another really powerful tool we have in Clojure is these transparent data structures. We have nice literals for typing them in really quickly. And as a result, they're everywhere. But even though they're pretty transparent and we can see values in them easily, of course, often you'll get a map back or a vector back and it'll be empty, or there will be some other reason that makes it not obvious. So perhaps you're querying some data, you're feeling really good about it, you are living the simple and easy life, and you get a user key, but it's nil. So your question is, well, what does user mean in this context? It could be a UUID. It could be an email, like maybe it's from a request. It could be a map containing some of those things. So here is where examples really come in handy. But first, another possible solution some people might reach for in other languages is types and type-based approaches. So we have records, which are nice for polymorphism, if you kind of have a problem that fits really well, but they're pretty rigid, and they're not really aimed at documentation. So scattering records is not really the move. We also have a cool project in Clojure called Type Clojure, and all power to them for this, I think, interesting synergy between Clojure, Lisp and typing. which are normally kind of oil and water. But it's not something you can just drop in your code base. It's not ready for production, and a lot of Clojurists might start a riot if you calmly suggest integrating types into the database. So I think a solution that really fits well into Clojure's strength is to use examples. So we have a whole variety of examples that you can use. So, and I've kind of broken them down by how much effort they are to use, to what extent they play into correctness, and what kind of documentation they provide. So one kind of documentation is like, well, what is the intent? That's kind of the spirit of this data. What is it trying to accomplish? The other is the letter, which is kind of like the boundaries, like what is allowed. So they kind of vary in what kinds of documentation they provide, and I will go through each one. So a doc string might look something like this. We kind of talk about what I think is really effective is to actually include these data structures as an example in our doc strings. So in this case, this explains that it results in a map and gives an example of what that even looks like, and also says that other keys are left as is. So it's primarily an example, but it also has a little bit, it has the flexibility to say, we allow anything key-wise. So those can provide basically both kinds. You can, in a doc string, spell out exactly what is allowed and what is disallowed. But you can also provide very realistic examples and kind of talk about nuances of what those mean. Another tool in this area is spec, Mali, and there's I think a couple others that are basically specifications. So those represent more effort, and they are more focused on the letter of the documentation, what is allowed, what can be in this data structure. They also provide something new. They're executable in a way. They can both validate data, and they can often generate a lot of data, so you can kind of probe your system and make sure you're not getting anything invalid back, you're not crashing, etc. So because that data is random, it is not usually very representative, hence it is letter. They are a little bit more effort to write than doc strings. At least you do need to kind of know these libraries. And so but they can be fairly low-key. You have just a couple things, and you can kind of break them down, which makes them pretty understandable, but may require you to, in a longer data structure, kind of go back and forth, going from a key to what that key means. But still, it doesn't take much time, in my experience, to get up to speed. So I would say kind of medium, low effort. And then generators are a little bit older, and they are really focused on correctness, especially property-based testing. That's where they come from. But in a way, they also provide kind of letter documentation, because while they're designed to tell the system what is allowed, we as programmers can obviously interpret that. It's just not necessarily as direct. And there is functionality for generating examples from generators, but those examples are from the entire probability space of what is allowed. So unless you get really lucky, it's probably not going to make too much sense. These are among the hardest to write. Testing single values, there's a lot of great functions provided for you, but if you want something that actually closely resembles the shape of your data, you have to write it. And along those lines, this is probably the slide I'm least confident about, that it is correct. It looks correct to me. I didn't have time to run it. But it's a lot less straightforward because generators have kind of their own mirror of Clojure that lets them generate the right types of values, and then you can combine them in clojureU ways, but it's not quite the same. So often it ends up being more effort to learn and to apply this if you want something really closely resembling your data. A new example we're really excited about is Fitsai. It's a new library from Lambda Island. And it is focused a lot more on realistic examples. So kind of more in the spirit, you can, if you go out of your way, set it up to produce random values. But kind of the intent and the easy path is to just provide examples. It doesn't have direct support for unit testing, but generating these values makes it really easy to integrate in your unit tests. And yeah, so these look quite a bit like an actual data structure you might see in your REPL. So popping it in to this factories file is quite easy. Another promising approach, which we haven't adopted very much in Clojure, is doc tests. I'm not going to go over this example because I think I'm running a little bit low on time. But this is a Python doc test. And it does, in addition to have the nice benefits I already talked about, it does let you actually run them. So you have validation. So your documentation will not drift away over time. And you can also see that you can kind of slip in some inline comments. So doc tests are pretty low effort, and they kind of serve both the spirit and letter, and they're actually natively unit tests. So kind of the final advantage of Clojure that I'm going to talk about today is Interop. This is one of the areas where I feel like the best solution is the one you already know about and is the most work. And that is probably to create to either have a very thin wrapper around Java because your users already know it or are in a position where they kind of need to know it, or build a really substantial library that makes the most of Clojure abstractions. But these can easily become kind of unintelligible because you may only see these Java classes when the abstraction leaks. So I think there's a couple of quick techniques you can use. You can upgrade Java in Clojure and take advantage of the improved error messages. You can also leverage some of the tools I talked about before. Like you could use REPL sessions. You could, in particular, or you can use some sort of example-based to generate the objects needed for Interop. And the other technique I would suggest is wrapping exceptions, particularly when you're going between levels. So like maybe you have a low-level API that deals with Java objects pretty directly, and you expect the users of that to kind of understand the Java classes. But to prevent kind of leakage between your low-level and high-level, catching exceptions on that low level so they make sense to a Clojure programmer who only knows the Clojure abstractions, I think can make it a lot more understandable. And here is our final detour, and I unfortunately have to give a small warning. There's going to be a little bit of static typing in this slide. And that is one technique I really wish we would do more in Clojure, that Rust does really well, and that is using error messages as an opportunity to teach. So this works across Clojure, but I think it's especially acute when doing Java interop because the messages tend to be, in my experience, really opaque and difficult to understand. So this message is pretty nice because it actually points out parts of your code that it thinks you went awry, and even gives you a suggestion. So that kind of thing is difficult to build, and this is probably overkill for a lot of situations. But I think it exemplifies the power of error messages to not just be kind of a speed bump, but also kind of, I guess, a ramp to better understanding. So there's kind of been two themes across there I kind of noticed as I was putting together this talk. One is definitions. Often systems that aren't clear, you don't know what exactly things mean. And the other one is context. You don't know how the parts are meant to be used together or how the namespaces relate. So hopefully the tools I talked about can help you achieve those. But really what I'd want to encourage you to do is kind of think about, as you design and consider different architectural decisions and kind of smaller scale decisions as well, how you are ensuring people have the context they need and also know what the names of things actually mean in your domain. Thank you.
So, thanks a lot. We're running a bit late, but I think we can take one question just for a change of the whole procedure today. I'm coming.
Thanks. How would you implement your last possibility to be able to give good feedback in error messages, where sometimes I don't have access to like the analysis of the compiler, you know what I mean? Like in the example you had, in Rust, they throw that during compilation, right? So they know the whole state, but in my library, I don't know the code of the user, right?
Yeah. So in a situation where it fails at, are you talking about like a syntactical error? Like it fails at the
syntactical, but
early stage?
in your last slide, you had the example of the Rust compiler telling you that you try to access something that you're not allowed to access. And I don't think we can, like, I can't throw this error, I'm sorry, I can't throw this error from my library, right? Because I don't know that the user tried to access something and I can't tell him in which line he tried to do it. So I think we would need tool support inside either the compiler or Borg dude can extend Clojure Condo a little more. He's not doing anything, right? Or something like that, I think.
Yeah.
Or did you already manage to do something like this?
I think if I had, that would be the subject of this talk.
Sorry to put you.
Yeah. So I think like if you just have an API function and there's like a syntax error in the requirements, like I don't think there's any way, like your code is never going to get executed. If you have a macro, there might be something you could do. I'd have to think about that. And I think macros are probably the area where it would make more sense for your library to do that kind of error, because in earlier stages, like for a common Clojure error, I'm not sure your library should have that responsibility. So, but yeah, that's an interesting question. I think in some cases you can, if you are evaling code, I believe you can catch a syntax error. That's probably not a robust solution. But if you want, that would be another angle to pursue.
So one of these days, we need to talk about the difference between a discussion and a question, but thanks. I'm sorry. Let's move on to the next speaker. So once again, a big warm applause